Welcome back, everybody. So let's take a look at the series given here. This series has some initial terms like ln of 1 divided by 1 squared plus ln of 2 divided by 2 squared plus ln of 3 divided by 3 squared, and the rest of the terms. But guys, this goes to infinity, all right? And this is equal to 0. Let's apply, for example, integral test. For the integral test, we need to take the integral of function, which in this case is ln of x divided by x dx over the interval that makes the function f of x be continuous, decreasing, positive, continuous, decreasing, and positive. So we can take a look at the graph of this function first using Desmos. Let me open up Desmos for you. Here we go. So this is Desmos, right? This is the behavior of this function when you have x. But remember that you always go back to n. So the function starts increasing, then starts decreasing. Well, it seems like the behavior of the function starts decreasing around these points, am I right? But I don't want to guess anything, right? Continuous, positive, and decreasing. So let's take a look at the algebra behind it. Of course, it's continuous. Of course, it's positive, but for decreasing part, well, what is that? To analyze being increasing, decreasing, we're going to take the derivative of the function. Decreasing depends on the sign of the derivative of the function. So let's take the derivative. F prime of x is equal to, here you have a rational function. So the derivative of ln of x times x squared minus the derivative of x squared times ln of x divided by x squared to the second power, right? Very good. So let's just simplify this as much as we can. We have 1 over x times x squared minus 2x ln of x divided by x to the 4th. F prime of x is equal to x minus 2x ln of x divided by x to the 4th. You can factor out x, you get 1 minus 2 ln of x divided by x to the 4th, and then we can simplify that, get x to the 3rd. So this is my derivative. And which interval this guy is? Increasing, decreasing, all right? You want to know what's the sign of this derivative. F prime of x is positive, f prime of x is negative on which interval? So we can decide on the boundaries for this integral here. Well, take a look. If x is positive, 1 minus 2 ln of x must be negative, so we get a decreasing function. So since x cubed is positive on 0 to infinity, we can just check 1 minus 2 ln of x. 1 minus 2 ln of x is going to be negative, where? So here you have 2 ln of x more than 1, or ln of x more than a half, or x is more than, let's see, e to power a half, or x is more than square root of e. Guys, it says more than, it doesn't have any equality. So you can say that, hey, instead of guessing, I can round it to the closest integer, and x is more than or equal to 2. So as long as your x is more than or equal to 2, you for sure can say that the function is continuous, decreasing, and positive. So take this interval. On this interval, the function f of x ln of x over x squared is positive, definitely, plus continuous, plus decreasing. Perfect. All done. Now you just need to take the integral 2 to infinity ln of x over x squared dx. Well, you need to write this in improper integral form. So here you have limit of 2 to t as t goes to infinity. Ln of, here you have x divided by x squared dx. And okay, for this integral, we need to apply integration by parts, right? Apply integration by parts. So here you need to have uv minus integral v du. So let us take u to be ln of x, dv be 1 over x squared dx, du is 1 over x dx, and v is the integral of 1 over x squared, which is negative 1 over x. So this integral becomes uv, we need to have the limit, remember that, a proper integral, limit t goes to infinity, and uv ln of x times negative 1 over x, and let's see, it's bounded between 2 to t, minus the limit of integral v du, v is negative 1 over x, du is 1 over x dx, and t goes to infinity 2 to t. Going back to just elementary stuff that you learn in integration. Perfect. So let's see. Here you have ln of t divided by t, and you have a negative sign. You're taking the limit as t goes to infinity, minus, here I have now ln of 2 divided by, you have another negative sign, so we get 2 divided by 2. This is for the first one. Then we can move on to find the limit of this integral. You have integral of, it's just plus 1 over x squared, which becomes negative 1 over x. And again, you have a limit 2 to t as t goes to infinity. For this guy here, if you plug in infinity, you get infinity over infinity, so apply L'Hopital's rule. And after applying L'Hopital's rule and taking the limit, you need to show step-by-step work, you get 0. You have negative 1 over t divided by 1 as t goes to infinity. This is just basically 0. And you have ln of 2 divided by 2. And here you have minus limit of 1 over t as t goes to infinity is 0, minus limit of 1 over 2, which is 1 over 2. So you have ln of 2 over 2 plus a half. So the integral here is convergent. So you can say that, hey, by integral test, my series is convergent. So this is the conclusion that we have. Let me just erase this part of the board. Since the integral is convergent, so the series is convergent as well. Again, the interval over which this function is continuous, decreasing, and positive is 2 to positive infinity, and basically you have, if you plug in 1, you get the very first term 0. So you can basically say that, hey, I can ignore some terms, finite terms of the series, and just take a look at the series as it goes to infinity.